Meantime, Colorado is bracing for strong winds tomorrow, especially in the foothills, upwards of 100 miles an hour we're talking about. And some of those gusts are going to be really strong. And that obviously increases the risk of fire.
Senior meteorologist Chris Bianchi is here to explain the mountain waves that could produce some of those strong winds along the foothills. Chris?
Yeah, so Kim, exactly. This is a mountain wave event, and that means that basically you get a big wall of really strong winds that hits the mountains, right? That 14,000-foot wall of rock west of us here in Denver. And when that hits, it's forced to rapidly rise. And whether or not it comes down the mountains, that is the question, but that's going to be what we talk about with a mountain wave. I'm going to explain that in just a second, but that air, as it descends, it warms what we call a Chinook wind, and that is because of compression. That air is forced to compress. And remember, when you're feeling warm air, what you're feeling are really fast-moving air particles. So when you feel the friction from that, so when you accelerate, you compress that air, you accelerate, and you warm it on up. So here's how a mountain wave works, right? Big wall of rock that I was talking about, that 14,000-foot wall of rock that we know is the Rocky Mountains. You get really fast-moving air that hits it. It's forced to go up, and sometimes it depends. Now, that descension depends on whether or not you've got this, whether you've got high pressure above the mountain or around the mountain, because air flows from high to low pressure. Sometimes what happens is you get some really strong air that's, you get what we call a stable air right up above here. So think about taking a straw and going like that. Sometimes you get that little forcing of air down the mountains. And at the surface here in Denver, we generally have lower pressure than way up there in the mountains. And so point being, if you can get that to take place, you get a classic mountain wave setup. So again, basically what you need, high pressure up here, low pressure down here. That forces the air to rapidly descend. And as it does so, it warms, it compresses. And sometimes it can really rush down, sometimes as far east as Denver, but usually that's why the air will kind of stop right at the base of the foothills. You get enough acceleration, but once you get past the base of the foothills, it has nowhere else to go. So sometimes when you're getting these really strong winds, basically one of the things to kind of keep in mind as well, in order to get a trash can knocked down, you need about a 28-mile-an-hour wind. In order to knock down somebody like me, 67-mile-an-hour wind. And if you want to topple over a car, usually it's about a 90 to 100-mile-an-hour wind. Depends on the exact size of the car and the dimensions of it. But in general, to knock over a person, it's about a 70-mile-an-hour wind. For a car, it's about 90 miles an hour. And we could be talking about winds this strong tomorrow along Highway 93 and points west. So maybe not a great day to take Highway 93 tomorrow, Kim and Phil.
Yeah, good advice. That is some serious wind.
Don't even attempt it. It's not worth it. You gotta find another way.
You know Highway 93, that's a rough go. Peach Peak Highway as well. Just try and avoid those areas tomorrow.
Delay it. Go some other time. All right.
Thank you.
Thank you, Chris.